Let us recap what we have been talking so far on the topic of C++. C++ is an evolution of the C programming language, and you don't have to use object-oriented techniques. They're in essence optional. C++ overloadable methods must be declared virtual, else you will not be able to have a polymorphic function in the child class. When creating objects on the heap using the new operator, you must free the memory later on after usage using delete, else you will get a memory leak. You must dereference a pointer when access its content, so you must precede the pointer name with an asterisk. References and the address operator are the same operator, the ampersand character, but do different things. And unexpected exceptions abort the program. Let's talk about some more important topics in C++ before you're ready to use it in the course. Constructors. There is no call to super to call the constructor of the parent class, but what you do is you link constructors and even initialize members via linked constructors. As in this example, you have a class called myClass which inherits from myBase. It has some members I and S, and the myClass constructor can be defined as :mybase, comma I911 as help. And again, the constructor is empty other than initializing the members. So this syntax allows you to initialize the members and call the constructor of the base parent class. You have to call, however, these constructors in the correct order, same as the declaration. And this code is exception safe. So you may not call S help before I911. I mentioned before that if you use the equal sign between on two objects, you get the object copied. If you don't want to copy the objects, you can declare all constructors of a base class to be private. So the class noncopy, it has a private constructor noncopy and a public function instance, which returns you one instance of the noncopy class. This can also be built into the singleton design pattern. If you want to copy custom classes that you create, you have to define a so-called copy constructor to handle the copying of classes if they have member pointers. So for example, the class copy ctor here has a pointer to an integer. So if you want to have a constructor that takes another class instance and want it copied, you need to create this copy constructor. And in the copy constructor, you allocate space for a new integer and copy the pointers, the contents of the copy object of P, the P of the copy object to the new P. Casts, which means changing the type of some object. There are several casts in C++. There are essentially 4 + 1 casts, and they are called dynamic cast, static cast, reinterpret cast, const cast, and the so-called C-style cast. The dynamic cast checks at runtime if a cast was successful and returns 0 if not. The static cast performs no runtime checks, which means you should use it with more caution. And the reinterpret cast overrules compiler's opinion about types. That means even if the compiler thinks these types should not be casted, for instance, it's quite common to cast a float to an integer or vice versa, but if these are completely different objects, and the compiler wouldn't allow you to cast that, then you can still call reinterpret cast and tell the compiler whatever, just assign this thing a new type. Then you use reinterpret cast. Const cast removes const from an expression, which is quite a dangerous thing. I do not recommend to do that. And the final C-style cast, which just means you write the value in front of the variable name with parentheses, or the type name, just ignores everything and just changes the type. So if anything, you should only use dynamic cast and static cast in your exercises. The other three I would not consider safe and should only be used in very, very specific circumstances. I've mentioned const a few times before. Const is essentially similar to the final keyword in Java, but it's used a lot more in C++. It's quite common to see const everywhere. For example, you might see something like const int pointer const get member const, or int const pointer const get member const as definitions of a function in a header file. The above lines are semantically equivalent, and the meaning of each const from left to right means the first const says the return value of the function is a pointer to const int. So it points to an integer that you cannot modify. The second const from left to right says the pointer itself is constant, so you can't modify the pointer either, i.e. give the pointer a new address. And the final const says that this method does not alter the object, any members of the object, and may also be called on const objects. So the best practice is to put const everywhere you can. This helps you reduce programming errors, makes things a bit faster under some circumstances, and also yields pure functions in the sense of functional programming, which has of course several good sides. The compiler checks if all the const constraints hold and may also optimize some things, which speeds up your program. For instance, you can use the compiler may change call by value to call by reference, which is generally faster, and directly use a value for int const instead of a memory object access. The problem is that the data is not related to logic if blocking the whole object, which means it's volatile. There's also the possibility, which you do not have in Java, is to overload operators. Operators in C++ are just methods with funny names, and you can overload them. There are some exceptions. You might not overload the namespace operator, double colon. You may not overload size of or dot, but you may overload lots of things like plus, minus, star, slash, double angle brackets, new, delete, and many other things. Also the array access element operator. And yeah, you can overload them like any other functions. So, namespaces. Namespaces are another way, in addition to classes, to bring order and structure and hierarchy into your program. You can define a class in a namespace, which has then a function, and then you define it as void my namespace : my class : dummy, for instance. You can also have what's called a scoped namespace, which just defines the function inside a namespace scope. And if you don't want to write my namespace : in front of everything, you can also specify to use the namespace globally by writing using namespace my namespace, and you can call my class : dummy. Let's summarize this up. The constructor should use auto pointer for allocating resources. which is the auto pointer is memory allocation that helps you with deleting, since it automatically deletes stuff for you, but that's also an advanced topic. You should not forget to write a copy constructor when you use a pointer member field. And when it comes to the forecasts, do not use the C-style cast, but the 4 other casts, preferably static cast and dynamic cast. Don't forget about const when you clarify your functions. The more const you can add, the better. Operators may be overloaded, and you may use namespace, but don't include everything into the global namespace.